My name is Ali. I am with Özyeğin University. I was at Cisco for about 9 years after doing my PhD. And then I've been consulting since then for the last 10 years. And I'm also a computer science professor. So today I'm going to talk about MOQ. Yesterday Will gave a good overview of what has been happening with MOQ. You are going to see mostly some demos and some working implementations. And our implementation is called MoQtail, and that's what I'm going to show you today. So, as a recap, a lot of people, probably know this, but some still seem to be struggling with. So, Quick is really like a multi-lane highway. There are multiple streams within a Quick connection. So you need to open a single connection with the server or another peer, but then there can be multiple simultaneous streams ongoing between the server and client. So this could be peer-to-peer or a serverless client. So let's say this multi-lane highway, single quick connection, but 3 streams are shown here. There's also datagram mode, so you can also send some unreliable datagrams over this connection. So on the sender side, we have, the whole Quick stack actually runs in the user space. So it's not really part of the operating system. So it's part of the Chrome browser, Safari browser, or Firefox and so on. So it's within your application. So it's, everything is in the user space. That allows us to customize the congestion control and retransmission machinery if you want to for our specific application. So there are 3 streams in this case, and then streams can be prioritized relatively to each other. So high priority stream could be your text messages, your audio messages, and so on. Medium priority could be like your screen share if it is a video conferencing. And then low priority could be like file sharing or video streams and so on, right? It's all up to you. And streams support, they guarantee that the delivery will be in order. So packets are going to be sequenced and the delivery will be reliable and in order. But there is no in order delivery among the streams, obviously, because high priority is going to make to the client way before than the low priority stream, obviously, right? So you got to make sure that you can handle that in your application. And then this is all a single quick connection, and who knows how many streams there are within a single quick connection. It's not going to be transparent. It's not going to be visible to the ISP or the network provider. So everything is going to be transparent. So if you need some sort of quality of service, I want to prioritize my stream 2, which is my screen sharing, for example, in this case, well, you got to actually use a separate quick connection. Your ISP otherwise won't be able to do anything for that. Now, with MOQ, what we are trying to do is we would like to separate the delivery plane from the control plane and the media plane. Right? In WebRTC, they are all intermixed, and then that's obviously makes things a bit more complicated. So we have lots of different applications, and I'm going to show you some here. So on one hand, we deal, when we focus about, when we care about scalability, DashHLS obviously comes into mind. And today, YouTube, Netflix, all kinds of those platforms, they use DashHLS or a variant of it, right? And scalability is pretty much unlimited. Like the more CDN edges you add, the more scalable you are going to become. And then the same thing for live streaming. So today, Olympics, World Cup, or Wimbledon finals, and so on, they can be streamed by millions of people without any problem in 4K. So that's not an issue either. Low latency extensions for DashHLS, they both exist and then they can be used, but we haven't really seen much traction on that front, to be frank. The specs have been around for over 6-7 years now, but and there are really good implementations, but the market hasn't really picked up yet. For interactive live applications like betting and gambling, that sort of thing, many companies or many content providers or owners, they seem to be relying on WebRTC or some sort of it, right? And with interactivity, obviously scalability usually goes down, and if you want more scalability, you need to give up on the interactivity and so on. What media over quick, we have 2 types of transmission. One is on the on the interactivity side, subscribe pops up model, and then on the on-demand side or live streaming side, we have the fetch support, which I'm going to show you today. This has been added to the spec in the last year or so, and allows us to support Dash or HLS type of applications. So the entire protocol is still a single MOQ transport, but it can work seamlessly into different modes. So one nice thing about MOQ is it is latency tunable. So on one extreme you have WebRTC, which really don't have any tuning mechanism for latency. You just you might have a small play-out buffer, but that's about it. The transmission doesn't really know anything about that. It's on the client side. For VOD, your buffering could be in the order of 45 seconds or even a minute, like Netflix. And MOQ can do both. It is quite quite a big feature of the protocol itself. So on one side we have publishers, and on the other side we have subscribers. And then if it is a video conferencing, obviously a publisher will be a subscriber as well. So media sources, they are individual publishers. They send the data. There's also a control stream where you send all these subscribe, unsubscribe, fetch, and other control messages back and forth. So that's a bidirectional channel, and then media goes only in one way. The same application can be run on web transport if you are in a browser environment, which currently what we support in MoQtail, but raw quick implementations are just straightforward. So MOQ is about scalable and really highly scalable distribution, and it is really a generic distribution. MOQ doesn't know anything about the media it's carrying. Whether it could be audio or video or text or image, it doesn't really care. So there could be all kinds of different applications where you can think of IoT devices and so on. So security cameras, drones, and things like that. And they could be publishers. And then at the same time, a bunch of databases or monitors or speakers or human beings or some other devices could be the subscribers. And this could be, again, a two-way traffic. What is important is that we have a generic MOQ CDN in between, and then this could be multiple CDNs. So I'm hoping Akamai will be one of them, Cloudflare will be another one, and so on. So you can actually buy these services, CDN caching capabilities from all these companies to scale your application. You don't need to deal with like SFUs and so on as you will do in WebRTC distribution. Okay, yeah, so you just focus on the publishers and subscribers in your case. Now, why MoQtail? We started developing this, earlier this year. You will remember that I showed a couple of demos last year, and then, in this conference and in some other conference, I've shown some other demos, and they were all based on the initial implementation based on MoQRS. That code base was not ours. It was, from Luke, who used to be attending the ITF meetings and so on. But later on, you might know the story. He kind of diverged from the ITF process, and then he started implementing things in the way that he wanted to. So we said, okay, we want to stick with the ITF process. We want to stick with the ITF spec and so on. So we created our own implementation from scratch. So also, just because you are compliant to the spec doesn't mean that everybody is going to be able to use your software. So we are trying to make it as easy as possible for people to experiment with this and then develop whatever application they would like to. So our current implementation stack is as follows. So at the bottom, we have web transport. And then if we are running in a browser, like publisher subscriber wise, we will just use the API provided by the browser. And most browsers today support web transport, but the leading browser is Chrome. And we have this W transport crate for Rust, for the relay, and then Queen crate for our quick layer. That's also open source. So the web transport crate and the Queen crate are not ours. We are just using them, and they seem to be quite popular. And MoQtail is what we are developing. So for the publisher and subscriber, we have Rust components as well as TypeScript components. And the relay, which is generic again, for whatever application you are using this relay for, it's going to be the same, and it's implemented in Rust. And on the top layer, until 2 weeks ago, I used to have only LOC, so low overhead container, which is the basic, very simplistic container format for media. So it uses web codecs, right? Audio framing, video framing, and so on. It's a very simple header mechanism, and it allows you to carry all these audio, video content. Now with CMAF, which we implemented in the last month or so, as you know, CMAF is the main streaming format for Dash and HLS. And just this morning I learned that the CMAF spec coming out of MPEG has won an Emmy Award yesterday. So the celebration will be in February, but the news just came out this morning. So congratulations to all those who were involved. This work actually started in MPEG in 2016, so almost 9 years ago. So we have a lower overhead container. We have, for the client side or for the publisher and the subscriber, we have the TypeScript components that support that, and then it uses web codecs API from the browser. For CMAF, we have Rust on the publisher and connected to an FFmpeg instance. And then for the playback, we have TypeScript and media source extensions. So it is demo time. I'm gonna invite Zafer, who is one of my PhD students and who has been the main developer for this project. So we are gonna have multiple demos, and pretty much all of them are online. I hope they were just working like 10 minutes ago. I hope they're still functional. So let's go one by one. This is what we showed just a couple of days ago in IBC. We started this project a month ago in mid-August, and Will from Akamai. And then Gwendal Simon from Snemedia, we have been a big proponent of the fetch mechanism. So not just for real-time conferencing, but also all these streaming type of applications, we should be able to use fetch, MOQ, right? So we thought that we should actually have a demo based on this MoQtail implementation that we have, and it should really enlighten people, and educate them how MOQ could be used in practice. So what's happening here is that I'm going to show you the demo, but here's what's happening. We have a live game, right? And then it goes through an encoder. In this case we use AVC, but you can use any codec FFmpeg supports. And then this company from Portugal, Sixth Floor Solutions, they have this nice product, I will say. So they get a feed of their live video, when the game is being played. And then they have this real-time AI detection of different events. So in a basketball game, it will be like a 1-point score, 2-point score, 3-point score, falls, plays, steals or blocks or slam dunks and so on. Whatever they can generate based on the real-time video. They send us some sort of metadata, and this metadata comes into our publisher, which has been implemented in Rust, and then also gets the elementary streams from FFmpeg, creates the MOQ groups, subgroups, and objects. Every CMF chunk is a MOQ object in our implementation at the moment, and that's only one frame. So we try to achieve low latency here. And every GOP, like a CMF segment, is going to be a MOQ group. So we have all these objects being published in real time, and then we have a relay, and then we have a subscriber. So this will be you on your browser. You will go to the website, ibc25.moqtail.dev, and then you are going to open a connection to the relay because you are getting a catalog which is going to explain to you what's available, in what codec, in what resolution. Just note that there is a single video track in this case, so there is no rate adaptation, but it's just a straightforward extension to this application. So in this demo, the main thing is this timeline events associated with the video, real-time audio and video, and everything is being published, and then the client is going to subscribe and it's going to receive all that information. So this is one quick connection. This is another quick connection, and I'm going to show you a demo. It's going to make it clear. So let's see. So at the moment, we have two relays, one in Europe, in Amsterdam. And you can see the latency, the ping time, 54 milliseconds from here. And then we have one in Chicago. That's on the other side of the world. And I'm going to pick that one just to show you. Oh, all right. Well, that's interesting. I thought that I was just... I want to share the entire screen. That's what I did. Okay. I need to exit from the PowerPoint. Sorry. Here we go. All right. Thank you. So we joined the game. Obviously, this is not a live game anymore. This was played in Portugal some time ago, but we are feeding the information to FFmpeg just like it was. We are pretending that it's live. So it's live encoding and then everything, and so it's so on the top you see media time. So it has been like 9 minutes 22 seconds since the game has started. So after a couple of hours, when the game ends, it just loops. Publisher time is the local time in where the publisher is. I think adjusted to our time zone, right, Zafer? Right. So subscriber time is our time, my computer's time, because that's my my player, and the latency is the difference between those two values. Now, you are gonna be able to see the settings over here. So let's see. The default latency is 1.5 seconds, as you can see, and the latency tolerance is 0.25 seconds. So as long as the latency is between 125 and 175, the player is okay. But you can change those settings, which I'm going to do now. So I'm going to reduce the latency to actually even 0.6. So what's going to happen is that you are going to see the value. So it should come down to, it should be around 335 and 0.85. So, and remember, this content is coming from all the way from Chicago. So that's already some network latency, right? So the latency we get is less than half a second. So which is pretty good. The way it works is that it tries to achieve the target latency. And if you, for example, I'm going to increase the latency a bit now, just to show you that. Let's say to 1.6. It's going to slow down the playback. So instead of playing at 30 frames per second, it's going to slow down to maybe 26, 27 frames per second for a while. So it will actually fall back behind the live edge. If I want to get closer to the live edge, it's going to increase the playback rate, so frame rate. Instead of 30, it's going to play at maybe 33, 34 for a while, and then it's going to reduce the latency. So you're not going to see jumps. It's going to play a bit more, a bit faster or more slowly, but you are going to get there eventually. So you can also adjust this playback speed catch-up rate. So 0.9x and 1.1x, that means only 10% faster or slower. You can make it larger or smaller as you like. Now, the interesting thing, I mentioned that this real-time event detection. So these are 3 points. You can filter the events as you like. Let's say I want to just see the 3 points. And this is the last 10 minutes, by the way. So this is a live broadcast, but we give you the capability to rewind to a point of interest based on your interest, right? So I want to see this 3 point. So it wasn't being fetched so far? All right, let's see. That should come a bit faster, but so this is the replay. So this is going to be a 3-point shot, right? So the live broadcast is still going on over there, and then this was a replay. So if there's another replay, for example, let's see another 2-point. So let's say you were watching the game, you went to the bathroom for like a 5-minute break, and then you come back, you want to see all the scores, all the shots that you just missed, right? You can open as many as you like, depending on your, bandwidth. Each of these are 2 megabits per second at this point. So video doesn't look very good because that was the only source video we were allowed to use in this demo. That's 2 megabits per second. And whenever I want to go back to the live, I just come back here and promote this, and then I can replay at the same time and watch multiple feeds at the same time if I want to, right? So all these different events. Unfortunately, these two teams are not very good, so there are not really that many scores, but it is what it is. So the latency is quite minimal, all the way from a game in Chicago. Let's pretend that because the publisher is in Chicago and we are in Europe, Krakow, that's already pretty good distance, and 0.6 seconds is easily doable. One of my other students who lives in Vancouver on the West Coast, he was able to get a 0.1 second latency from the same publisher, even like with all the fetch capabilities and so on. So the live feed is again pops up, subscription, and then all these replays are based on the fetch. But it's the same quick connection, and they are all prioritized accordingly and so on. For example, in this case, we give the highest priority to live stream because we don't want to pause the live while we are trying to replay something, right? But in your use case, it could be something totally different. Any questions before I close this demo? Yes?
Does audio work?
Huh?
Does audio work?
Yes, it does. Yeah, it's just not here. Yeah, okay. I mean you can hear or do you speak Portuguese?
No, I don't. But
okay.
I just wanted to see that everything goes mostly with audio.
Yeah, there's audio. Yeah, there's audio. So.
Mais alguma alteração? Não, para já.
And speak Portuguese here?
Sporting já com muitas mexidas no seu ciclo. Penso que a lista.
What's that?
They're talking about the game.
Yeah. Okay. So that's good, right? So one nice thing we implemented, unfortunately, we weren't able to show in IBC because of all the noise in the in front of the booth. So whenever you are playing multiple videos, obviously you don't want to play the audio from all the sources at the same time. So what my student was able to do was whenever you want to hear a specific video audio from a specific video, you just hover your mouse, your cursor to that video, and then the audio will just come from that, and the others will be, almost muted. So, it doesn't really make any sense to us because none of us spoke Portuguese, but I hope it worked. So, any other question before? Yes.
Is it over the same quick connection or
single connection? Everything is happening. So obviously it's a UI issue, but you can open as many as like 16 replays at the same time with +1 for live. So, and everything, and remember there's a catalog track, which is your like playlist and so on. There is timeline track, which is broadcasted every 1 second. So as soon as a basket or a fall or 3-point happens, it's gonna show up here in 1 second, right? That's another stream. So audio, video are separate streams. So it's like, there are so many streams going on in parallel here, but they're all within a single quick connection, so that we can prioritize accordingly. If they are in different quick connections, there's nothing you can do. They're gonna be running independently. So that's not what you want. Yes? Yes?
If you change the latency, so in video we saw that it accelerated or it slowed down. If you have audio going on at the same time, are you also speeding it up and slowing down to synchronize?
Yeah. So, if I do this, it's now 10%. So 10% is more like borderline 6% for normal people. If you are quite picky, you are going to even notice like a 3%, 4% slowdown or faster playback. I can, but my parents cannot. It depends on the audience. If I increase this to, let's say, all the way to 50%, that's going to be crazy. I mean, people are going to be running like this, or they're going to be running like this. It's not going to be much fun. But that will allow you to catch up faster, right? Obviously, because your variation is larger. And with audio, 50% sounds a bit funny. Yeah.
Hey, Ali, I was actually going along the same lines.
Oh,
but,
okay, yeah.
As a musician, that would drive me nuts listening to music, right? You
This is not music. It's
No, I
It's
understand that.
Portuguese, so we are okay.
Não é música, é português. Yeah, got it. But you could conceivably just shift, right? And so like in a music application, you just say,
Yes.
I want to just seek directly to the latency that I have and just have it skip. Is that like the technique you would use for that?
So our algorithm is not very sophisticated, but there is also that feature. So if you are, let's say, sometimes your connection or your Wi-Fi is gonna suck, right? You are gonna be at a latency of, let's say, 20 seconds because you were going under a tunnel and then your connection kind of stalled, so you didn't get any new frames, right? So in that case, when the connection comes back online, the client is gonna see, hey, look, my target is 0.5 seconds, but I am 20 seconds behind now, and there is no way that I can catch up to this. So I'm gonna skip all the way those 20 seconds. I'm gonna be within like half a second range of the current live edge. Yes, we have that logic as well. So, but it has to be quite behind the live point so that to trigger that, because you don't want to really jump the content unless it's really necessary, right?
Like I said, if it's music, then you care.
Yeah.
Unless it's music where it's going to really disturb the experience by having it, speeding up.
So the key word over here is pitch preserving audio playback. I mean, for video, it's not really that important. I mean, looks like there is some playback frame rate variation right now. But as long as you reserve the pitch, the humans will still sound like humans. So guys are gonna sound like a guy, not like a female person. But for music, I think that 6% threshold is even lower.
Well, I mean, the reason I bring this up is we did this exact same thing with WebRTC back in the day, and our clients who were doing concerts and stuff, they hated it, right? And it became a real problem. So we had to basically turn it off for the certain use cases,
Yeah, exactly. So, I mean, that part has nothing to do with MOQ, obviously. It's just a player logic. But the idea over here is, so it looks like my latency has increased a bit. So, I don't know what it was. Okay, it's still within the target. So if I increase to, let's say, 3 seconds, it will slow down the playback. As you can see, the players are slower. Now they are back to normal frame rate again. I think there was another question. Yes?
Yeah, I had a question about the
mic.
Sorry. My question was about the timing measurements that you're doing up there.
Yes.
And I was wondering how you're carrying out the publisher time, subscriber time, and media time in the packaging layer that you have shown us.
Yes, very, very good question. So subscriber time is just my local time, my computer's time, right? And we expect my computer is NTP synced to timeapple.com. And Will tells me all the Linode service where our publisher is running, they are also very strictly synced in terms of time, NTP synced. So we should expect they are more or less the same, right? They are on the same page. Now, media time is just, how long it has been since we started the game, right? So like from frame 0. So that's actually inserted by FFmpeg. And publisher time is also something inserted at the FFmpeg using the PRFT box, producer reference time box. So that's actually an MP4 box where you can put different versions of time so that information is going to be carried all the way to the client. And in this case, it's going to be end-to-end latency because that's right after the encoding. Actually, this doesn't include the encoding time, which will say, let's say, another maybe 30, 40 milliseconds. So you can do it before encoding, after encoding, before packaging, after packaging, before the publisher, after the publisher, before the relay, after the relay. So you can actually print out the whole, where the latency is being spent, right? So that the box you are looking for is PRFT, but that's a CMF MP4 stuff. So you need to do some like RTP header extension or something like that for WebRTC to get the same thing. Yeah.
Hey, thanks.
Sure. Any other question?
I have one more question. I'm here. Sorry, on your right. Here.
I can see you.
Here.
Oh, okay.
Do you happen to know how browsers currently behave with the caching of the media right now? The current implementation in regards to media over quick, depending on, I don't know, for example, the playback segments seems something like the browser could cache. I don't know if that changes depending on the protocol here.
Whenever, let me show it to you. So actually, let me just automatically close all the replays. So whenever I click, I mean, you see these two games really suck. I mean, there is no anything at all on this time period. But let's see this 3-point shot. So this stuff is currently coming from the relay stuff. It wasn't cached at all, although maybe it was played in the player like a minute ago, right? So it's not cached at all. So even if I go to this event, let's say this happened like 23, 22, so just a while ago, just a minute ago or so. So this is also coming from relay. So we don't cache anything on the browser at the moment. Do you think we should, or? I mean, we don't, I mean...
I thought that the browser maybe would cache some stuff automatically, like, and maybe with HLS, I guess.
Well, some certain, static content might be cached, obviously, some segments. But in this case, this is purely coming as a mock object, so there is no way for the browser to cache, right?
Okay.
There's not. Yeah, there's no caching.
Okay, thank you.
So even if you just missed a second ago, you want to fetch, and then it will come from the relay. And I guess that's something the content sports providers want, because they don't want any copying or pirated content being rebroadcast and so on, right? All right, last chance for any questions. No? All right. So this is it. The second demo. This is something we implemented the first demo we had, and then we showed this in Berlin in MediaWeb Symposium, and then later a month later in July in SVTA segment. So this is going to be a video conferencing, and Zafer is going to join to this. So this is also open to anybody. Demo.moqtail.dev. So I'm going to type my name. And then we are going to give a room name, just like you are joining a Zoom session or WebEx session and so on, right? So this is me. I am waiting for someone else to join. And Zafer is here, right? So let me turn on my camera. Okay, let me stand here. So, so this is like, this is a demo room, and as you might guess, we are paying for AWS for this, so we limited the number of users in a single room to 6, and limited captive video bitrate as well, because we are paying for the outbound traffic. But Zafer's traffic is going to the relay and then coming to me, and then my content is going to the relay, and this relay is in Frankfurt, right? So in Frankfurt. And then it's going to his computer. So there could be someone else joining, and then it could be the same thing. So the latency, I see from Zafer is about 100 milliseconds, so that's about 3-4 frames cycle. So there is audio, there's video, you can share your desktop and do all kinds of things. There is chat, there is support for emojis. What else you could want, right? But here is the nice thing. So let's say you were in a conference call with your boss or with your advisor, and then he asked you a question and you weren't really paying attention. Maybe you were visiting another website or watching Netflix. So there's a little blue button here, which is rewind. So what you are going to do is that, Zafer, can you count to 1, 2, 3, 4, 5, and then I'm going to rewind? And then let's confirm whether Zafer has counted correctly or not. So this will be just a rewind window with the audio as well again. And while the conference call is still going on, you are just able to review what your boss or advisor had to say, right? So, and then this is last 10 seconds in this example, but we could do all the way back, or we can have a similar timeline here since the beginning of the conference call. So you can scroll, and see what people had to say, right? In this case, obviously, we are not really rewinding the entire conference call. That will be something different, but you were interested in what this guy had to say, so we are just rewinding that person. And same thing for his screen share or for his video and so on. So this allows you, I can replay it, I can close it, and then if I rewind again, it will be the last 10 seconds again, and so on. So this is really like, what we call video conferencing with time travel. I know it sounds really fishy, but it is what it is. Any questions here? This is the video conferencing side of MOQ that, many people actually had the vision for. Oh, MOQ is going to replace WebRTC. This is what we are going to have. The first demo was streaming. This is video conferencing.
Yeah, Ali, are you trying?
Oh, okay.
Yeah.
Yeah, sorry.
Are you sending the chat over the MOQ
Yes.
data channel as well?
Yes. Yeah.
There are 3 tracks, audio, video, and chat tracks.
Yeah.
So they're all same connection.
We are going to separate the screen sharing, but yeah, you get
So
the idea.
you had the video tracks and the chat, the text chats.
Yeah.
As separate track.
Yeah.
Very cool.
Yeah. And then we are going to separate the screen share. Right now the video is it's 200, 300, or maybe 400 kilobit per second. You can see all the statistics here, like looking at the codec and the resolution information and so on. And, okay, we have someone who showed up and then just left the call. Yeah. So we are going to make the screen sharing a bit higher resolution so that it looks clearer on the screen and so on. Again, there is no rate adaptation or simulcast in this case, but that's just a straightforward extension to this.
I have another question. I'm here on the right.
On the right, yes.
Yeah. How it behaves under a poor network, and are there any advances in the congestion control in the browser?
Yes, well, the congestion control is going to run on the sender side, so you can just you are able to affect how your traffic goes to other users, right? So there are a couple of things that we have done, and then also we plan to do. So let's say my connection is very poor, right? Maybe he has a great connection and I have a poor connection. Obviously, I may not be able to receive his traffic, and maybe more importantly, I will not be able to send my traffic, right? So in this case, maybe I'll just cut off my video and then send audio. Or since audio is higher prioritized than video, it should actually work that way anyway. Maybe I'll stop screen sharing, and so these things are prioritized at different levels, right? So the sender is going to do its best to send the highest priority traffic to the other side sooner than the others. But even if you don't have bandwidth for that kind, to be able to send that, well, they are going to be dropped because the sender is going to understand that this is the latency budget that I was given. Since it's already past deadline, I'm going to skip them. I'm going to drop them, right? So you can cancel those quick streams and then start a new quick stream once your connection comes back online. So.
Yeah, but is that only, the granularity is only that I can just stop sending the stream or start sending some stream? Or can I, for example, if with WebRTC, when some frames don't arrive, can I just forget about them, or they are already transmitted because of the congestion control, which forces retransmission of all the frames?
So in this case, we are still using quick streams, which again, as I said, support in-order guaranteed delivery, right? But as soon as I understand that the rest of the frames in that group, in that let's say 5-second group, are not going to make it, right? Because it's going to be way past their deadline. I'm going to cancel that stream, meaning that I'm going to drop all those frames in the ground, and I'm going to continue with the next group, which will start its own iframe or keyframe, whatever, right? So I can do that. Another thing is that I can try adjusting my encoded bitrate, because I am the encoder myself, right? I can, instead of at 400 kilobits per second, I can try sending at 100 kilobits per second, right? So I can do that too. I mean, all of those have different advantages and disadvantages, as you know. With Quick, you can decide what to do, right? Just because it's still reliable doesn't mean that you need to send them anyway. You can cancel the stream anytime you want.
Okay, thank you.
Yeah. And then we don't support quick datagram mode yet, but if you want to send this in quick datagram mode, obviously there won't be any retransmission capability, and it will work just like the way WebRTC works today. You send and forget about it. So hopefully they will make it. Yeah. Another question? Yes.
Yeah, just a really quick question. You mentioned datagrams, but datagrams, they don't support the order, right? In Quick.
Say it again.
So you mentioned it could have been like implemented using pure datagrams, but datagrams, they don't support the order of frames in Quick, right? So would it like add some complexity on, or
it might, yeah.
It's just like an idea, because I was just thinking the same. If it's possible to transmit video using.
I mentioned that LOC, remember, low overhead container. So there will be some sort of framing. So at the client, you can still put things in the right order before you feed them to the decoder.
Okay,
so
got it.
You need something like that. Yeah.
Yeah, thank you.
Yeah. All right. Okay, thank you. So let's continue. Okay, this is actually the demo I showed last year in this conference. It's still up there. If you go to moq.streaming.university, this is before we had MoQtail, so that's why the domain is different. We had a paper from 2024, last year in MemSys as well. So this is where you can compare media over Quick, and then in this case we have client-side ABR. So the client, this is the Quick client. You can enable or disable it. It's really a very engineering-oriented UI, so it really is not very nice, but there are multiple tracks here. And at the same time, this is low latency Dash, powered by Dash.js, something we also contributed to quite a bit over time, over the last several years. So you can compare the latency coming from the same source, and then you can see how the ABR works and things like that. Obviously, ABR is still like an open investigation. I mean, we need to look into that. I mean, we have done a lot of ABR research for Dash HLS, but there are still some things for MOQ. This is a new demo that was developed by another set of students over the last year. So this is synchronized VOD. So this has nothing to do with live or video conferencing or anything like that. So let's say you have a bunch of friends who decide to watch Big Buck Bunny together, and then you could be in different parts of the world. So you go to this website, you click on the share play, and then you create a room yourself, right? One of you is going to be the leader, the others are going to be a follower, obviously. And whatever the leader does in this timeline, like it can scrub back, forward, jump back, and so on, it will be fully synchronized for all the viewers. And then we are using MOQ for this. Obviously, you don't have to, but this was just, we wanted to show that MOQ can be used for on-demand content as opposed to just live content or real-time traffic. So there's an IETF draft that we wrote a while back. I think it has expired now, but it explains how things work. So we still have a lot of things to work on, not just the IETF working group or my research group, but I guess as a community we have a lot of things to do, like congestion response policies. Back to your question, what is the best congestion response given a situation, whether we are in a video conferencing application or live streaming application and so on. Selective drop policies. So the relays are going to be somewhat smart in terms of, hey, look, this packet or this stream is not going to make it. So, I mean, it's just a waste of time or capacity to send this over, so I'll just drop this off, right? And subscriber side, like sender side or client side adaptation logic or bitrate selection logic, whatever you want to call it. And then prioritization schemes. Everybody has an idea on this. I have my own, so probably there is no single truth in this. We really need to investigate what is right in which scenario. And then scheduling strategies. Obviously, when you have multiple streams going out from a relay, how we are going to prioritize or how you are going to schedule things, right? Within a single quick connection, you know what to do, but among multiple quick connections, that question has not been answered yet. So that's it, guys. So the demo, both demos are available online, ibc25.moqtail.dev or demo.moqtail.dev. The source code for the video conferencing application is also online. We haven't open sourced the IBC demo yet, but we will very soon. We just, as usual, we saw some bugs during IBC, so we need to fix them first. And that's it. And please don't abuse the relay. I mean, we are paying from our own dime for this. Please don't abuse it. All right, thank you.
Last chance to ask Ali any questions. Dan.
Yes, Dan.
So I have a question. Sorry. DRM. Where are you with DRM and MOQ?
I am personally against the use of DRM for anything.
Yeah, okay. Now, when you're looking at baseball games, it's kind of inevitable.
Yes, for sports especially, right? And if we use CMAP packaging, and then I think we are going to use CMAP packaging for such applications, DRM is just going to come along with DRM, common encryption and everything. There is nothing that relates to MOQ itself. I mean, the transport itself is encrypted. It's all quick TLS and things like that, right? And then on top of that, you have DRM. If you want to secure your video conferencing, maybe you do, I don't, but maybe you do, then I'm sure someone else is going to come up with a solution for that. I kind of don't care. Yes, Dan.
My question, sorry, you might have already said this. I had a meeting, unfortunately.
Sure.
What was I going to ask? Oh, yes, you said about not abusing the relay.
Yeah.
Can you just switch this over to using Cloudflare's new relay that they're letting people use for free? Or are there incompatibility issues? Like, where's the stack? Where's the draft? Where's the position?
They're still being recorded, right? Are we?
Yes.
Let's wrap the conference and we can have the...
That's a talk later.
Yeah, but the short answer is, Cloudflare just came up with that relay just a couple of weeks ago anyway. So we didn't really have the time to test and anything like that. But their relay is quite behind the current version. We are draft 11. The actual draft is 14 now. We are draft 11, and Cloudflare's relay is 0.7. So there are a lot of things that they relay. Fetch is not supported by any other relay than ours. So ours is the only option. Now the question is whether Cloudflare is going to accept our relay to run on their machines. That's the question I still need to ask and get an answer from Cloudflare. But then otherwise, we will be more than happy, because AWS is just a big,
expensive.
Yeah.
All right.
But to their credit, we got a lot of AWS free credits, so we are just spending them. But as soon as it's over, I guess we are going to be done. Yeah. GCP, Google, yeah. Well, yeah. But frankly, again, our AWS server relay works way better than our Linode server at the moment. We don't know why. And Will doesn't know why either, so we are going to look into that as well. So.
Either way, when the credits will be sober, there will be no hangover, as the as the sticker says. So, any other final questions?
So please use the source code, report the bugs and things like that. We want to really make this a community effort. Yeah.
Okay. Thank you very much, Ali.
Thank you.